Well, you're all here to see retaining walls in Civil 3D, I hope. Anybody in the wrong room? No? That's good. Ooh, that's not good, is it? Okay, I'll run it on the other one. Why not? And this will have to go here. Right, so my name's Joe. Hi. I live and work in the UK, and I've worked in the Autodesk channel since 1986. That's nearly 30 years using AutoCAD. The first version of AutoCAD I used was 2.17J. Don't know why I remember the J. Essentially, I'm an educator. I teach people. I'm a trainer. And I like to deliver complex topics in an easy-to-understand fashion. So hopefully, by the end of this session today, you'll understand what is potentially a difficult topic. Yep. Let's run over here and see if my clicker's working now. Yeah! But I'm going the wrong way. Yep. Now, I've got some interests. I'm into skiing, beer and wine, and comic books. Not all at the same time, I hope. Just for interest, I do collect old American comics, particularly 50s and 60s. Things like Superman and Flash and Batman and Wonder Woman. Ooh, good. Wonder Woman. So, if any of you are into that, please drop me a line and maybe we can exchange some books. Yeah, I'm going the wrong way again. Yeah. I used to own a reseller in the UK, and I sold it a couple of years ago to Greytech, and I now work for Greytech as a consultant. So, you know, my job is now entails doing what I want, which is great, isn't it? You know, I can pick and choose what I do. Yeah, and retaining walls is actually quite a passion, believe it or not. So this is Greytech, the company I now work for. They've got 26 offices worldwide. 30 years of experience, and they pride themselves in putting engineers with good skills in the right position to deliver to their customer base. A recent acquisition in Texas, AutoCAD, has been bought around about a month ago, so they're now part of Greytech. Yeah, which is great. Las Vegas, welcome to Las Vegas. City built on sand and $5 lobster. You know, you'll always get a happy ending here as long as you're prepared to pay extra. That's the first time I've spoken here, so you'll just have to forgive my nerves. And this class was inspired by another class that I saw back in AU 2013 by the gentleman you see on the screen. I don't know whether anybody attended that class, but it was inspirational. And I'm taking, say, 5% of that class, and I'm expanding it, yeah, so that 5% is going to be covered about 60% of this course, yeah, and I'm going to make it simple and easy to understand, yeah. Hey, it's my first time speaking. Please give me feedback. That's my Twitter account, Joe Axmax. Strange name, I know, not very professional, but when I used to play video games in the 80s, that's what I used to put on the ice score tables, and it sort of stuck, you know. So please feel free to feedback at the end in the AU fashion and so forth. Now, I got thinking about Las Vegas, and I thought movies, famous Las Vegas movies. Yeah, and there's some pretty good ones up there. Honeymoon in Vegas, remember the Flying Elvises? That was brilliant, wasn't it? But those are some of the most famous movies. My favourite is Dodgeball. Has anybody seen Dodgeball? Yeah, it's a great movie, isn't it? Yeah, absolutely fantastic. Now, I did ask permission of Fox to use some clips for Dodgeball, but they're in some sort of legal wangling with a third party, so they didn't give me permission to use clips. But what I'm going to do here is I'm going to include some quotes from the Dodgeball movie to emphasize certain points. Yeah? And for example, that's me there, taking the bull by the horns. It's a metaphor. It really happened. Okay, that's a quote from Dodgeball movie, but a lot of you wouldn't have realized that, yeah? So in order to, emphasize the point and make it known that it is a quote, I'm going to pick on someone. And this guy here has stood up for the task. So whenever I quote something from the Dodgeball movie, I'm going to address it to you. Okay. Right? Sorry, what's your name, sir? Leo. This is Leo. Thanks for helping me out here, Leo. Where are you from?
Reno.
Reno, not very far away then. Yeah, cool. So, Dodgeball. There are some pretty risque quotes in there, so I've given this a PG-13 rating. Yeah? I ran it past my 12-year-old daughter, and she told me to grow up. But hey. So this class is all about retaining walls. And, we're going to show you methods of how to create them. We're going to introduce Subassembly Composer. Now, I know you might have already sat through a Subassembly Composer demonstration. And if you went to the session before this one, the Ramp It Up one, did anybody go to that? Yeah? You're going to find that the Subassembly Composer is quite basic compared to the detail he went into. But, I'll make it simple. And we're going to export the final model into Autodesk Inventor. And if we time, I'm going to show you how we can do a round trip to Revit as well. Yeah? But basically, the class stuff, in a nutshell, you're going to learn how to design variable height retaining walls in Civil 3D. Yeah? And at the end of this session, this is all the bump that's in my handout. You're going to be able to design a retaining wall, understand the principles of targeting, look at Subassembly Composer, and extract the model into Revit or Inventor. But in a nutshell, yeah, you're going to be able to design a retaining wall like that at the end of this session. Yeah? And you're going to move it into Inventor or Revit. Yeah, so you've got some good things to look at. Now, also in the bump, I put on my notes that this course was for all levels. Some of you guys put your hand up there about going to the Ramp It Up thing. Now, you're obviously quite advanced users, but I'm sure there's people in here who are also beginners, basic users. So that's quite a bold statement, isn't it, for me saying that we're going to essentially deliver this course to all levels. One of your famous statesmen said, you can't please all the people all of the time. And because there's a mix of people in here, I aim to please all of you some of the time. Does that make sense? So some of you experts may think, oh, I've seen this before. And some of the beginners might think, oh, that's a bit over my head. But on average, you'll all get something out of this session. Yeah. Have I missed something? Come on. I'm making screencast presentations of this. I know the session's been recorded at the back. Yeah. But I've already made screencasts of the instructional demo, which you can go to the AU website and you better download them. I've not put them up there yet. Wait till I fly home, sleep it off, have a beer, and then I'll put them on the session, yeah? And I'm splitting this session into 3 parts. Remember, on the AU website, the supporting documentation available. Has anybody downloaded this yet? Cool. The way I've done it is I've made it so you, yourself, once you've seen this session, will be able to deliver the same session to your colleagues, your peers, almost like a training course. So I've documented it in a step-by-step process. Yeah, step 1, do this. Step 2, do that. So if you, at the end of this presentation, you feel comfortable, you've got the documentation to refer to, haven't you? Yeah. And it takes about an hour to run each hands-on class if you want to do that. Yeah. Questions? Well, no problem, but please wait until the end of the class, mainly because we've a lot to cram in. Yeah. I timed it yesterday and it was about 1 hour 45 minutes. Now I've only got 1 hour 30, so I might have to skip over some things quickly. So please wait until the end for questions. Retaining walls, well, I got this off Wikipedia, so it might not be true. We're going to look at these types of retaining walls in Civil 3D, the gravity type, the pile type, the cantilever. We're going to focus on the cantilever type of retaining wall. But when we export the model into Autodesk Inventor, we're going to look at other things like wall anchors. I believe you guys in the States, you call wall anchors dead men, is that right? Wow, that's fantastic. That's something I only learned yesterday. And there must be a history behind that, and I was going to look it up, but I never did. Yeah. And here's some retaining walls. I just took a walk around my town before I flew out here. And retaining walls are often used to create space. Yeah, particularly to make space in plots of land or to hold things up, or on corridors to make sure the corridor gets into town and that type of thing. These are very simple walls. Most of them, though, tend to have varying heights, not simply flat. And this is holding up the access road to the station car park in my hometown, and it's a varying height wall. Some have their reasons. The reason I took this is a very difficult picture to see because I had to stand on an intersection to take it. But that wall was built because a little old lady lived in the bungalow, the little house at the top, and she complained and she got the media on her side, and rather than just knocking it down, they built a retaining wall. And that was a fantastic story. There was 6 months of legal argument, and they ended up putting a wall like that just so the little old lady didn't have to move. You know, I mean, most of the time it just gets knocked down, doesn't it? This is my favourite wall. It's in the centre of town. It holds up that tenement block, 25 metres high. It goes for about 1.5 miles along the corridor that brings the railway into town. Yeah, and it's a fantastic feat of engineering. Yeah, but we're going to look at how we can create these in Civil 3D. I think the first thing I want to show you here is that we're going to be looking at understanding the site that we're going to look at. Obviously, you know that I'm from the UK, yeah, which is there. And this is the United Kingdom. This is England. Not much happens there. Good at making a cup of tea, though. Yeah. Nicest cup of tea in the world. You can't really go wrong. But our site's not in England. Oh, sorry, that's where I live. That's Bradford. Has anybody been to Bradford? I wouldn't bother. It's a shithole. Anyway, that's Scotland. This is where our site is. Now, Scotland's famous for a couple of things. Men wearing kilts and golf courses being one of them. Bagpipes and the lot. And this is where our site is actually going to be. Now, if you actually look at that outline of the UK there, I actually got that from a mapping company in AutoCAD format, and it had all the little islands around it. And I had to remove those to make it look basic. And what it does show is that Scotland, do you see up there at the top? It's got like a penis on it. Which you can't really tell. So I feel sorry for the people who live in Campbelltown, which is on Scotland's penis. Anyway, we're going to be working in just southwest of Glasgow. Those are Scotland's 2 largest cities. The plot of land that we're working on is very high value because it's adjoining open countryside. The problem is the relief on that land is excessive. Yeah, you can see by the contours on the surface there that came in from Civil 3D. And because it's high value land, the usage, the client wants to build housing on it. But to build housing, he's going to have to hold back some of that relief. He's going to have to put a wall up. And that's basically where we go on that. Yeah, you know, I mentioned skiing. I'm a skier. Well, Scotland has some ski resorts, yeah? But you know, Leo, I've got better runs in my shorts. Oh, come on, guys. Okay, let's have a look at this in Civil 3D now. Let's see where we go with this. So, 1, 2. I'm on the wrong one, haven't I? I am on the same monitor. I'm not using the other one. Right, so I'm flipping between things because my other machine's not giving me any fun. So let me open up a drawing so we can see where we are. Come on, guys. Don't tell me we're crashing at the first hurdle. Do I kill it and start it again? Possibly. How embarrassing. Right, let's start again. Civil 3D. I assume everybody in the room does actually work with Civil 3D in one form or another. No, what's happened? Boom, boom, boom. That's nothing on screen, is it? Come on. We can do it. Doing number 5. Ah, that's better. Way. Problem is, I'm not on this screen anymore. Oh, come on. You guys are going to have to help me out here. Connect to projector. Duplicate. Yay! No! Oh, disaster. Let's shut down, restart. Right, okay. Well, my apologies on this. What I will do is I'll try and flip to the other PowerPoint if I can, and see if I can get to the point roughly where we are while the machine is restarting. Yeah. Because we're actually going to look at, creating a surface model like so. Yeah. And when we come to build a retaining wall, it's important that we have tie-in. How many times have you done a Civil 3D project and you've got the surface perfect, but not at the edges? Yeah? And it just doesn't tie in correctly with the rest of the model. So I'm going to be very mindful when we design our retaining wall models here that we have tie-in to the existing ground. And you'll see when my machine actually finally restarts that the road that I've driven around this model, I'm going to use that as a tie-in point. Oh dear, that's not looking good. So Control Alt Delete, let me log in. Let's see if we have another type of input here. And we're on number 5. So come on, please, we need to see the screen. But yes, no, sadly I see nothing on mine. Function 4. Okay, guys, I'm really sorry about this. Bad.
What do you got going on?
Nothing.
Okay, you need to get this up on the screen?
Yeah.
What are you on, number 5?
5, yeah. It comes on here.
Just want to make sure we're still good.
I can see it on the screen there, but not on here.
Yeah, that's not good.
Yeah. I suppose I could put a table at the front and just look at the screen like so. Yeah. Oh, personalize. Display. Now, connect to projector is duplicate. Yeah, it's duplicate. I've tried that and the resolution goes all funny.
It does.
Maybe you can just alter the resolution now on that screen.
I could, but it's not putting it up there.
Mm.
So, it's just on there.
I have just done a reboot, so
It was up?
it was. Just try changing the resolution there if you could.
Exactly.
Adjust resolution. Right at the top.
Doesn't give you much, but I can change it.
Yeah. Well,
Hold on. I'm getting somewhere.
you're getting somewhere?
I think so.
No, nothing.
There's something.
Wait, we've got lights, so can we duplicate that?
So
Yeah, we have something. We're extending.
let me switch
It's
it
this
back
third
to
monitor. What's the
export.
third monitor?
Yeah, I've seen this on one other set. So we need to go into the management.
Right.
It's a NVIDIA control panel.
Yeah.
Oh, hold on. That may not be the graphics properties, I think. So, I mean, that's extended. You could put something over there.
Mm.
So you can present, but
Yeah, I need to see. Yeah, I definitely need to see it. Well, sorry, gentlemen. Yeah, and ladies, of course. Yeah. That. Ooh. I think it's the Intel graphics card that's causing the problem. I've got an NVIDIA in there.
yeah. Well, I saw another guy do something right in this thing.
Right.
If you need to move forward, I suggest put the laptop this side. And
Right.
you can-
Okay. Let's go for that. At least we'll have a. Right. That'll do.
Let's pull you closer to the screen.
Right. No, I think
Oh, you know what? There's two tables in there.
I can see from. I can do it from here. That's fantastic. All I need is now the ability to. So how do we get it on?
You have to slide it over to the screen. Try going this way. Take that window that way.
Right. Okay. Yeah, and I can do this. Right, we're a second away from Civil 3D restarting. I do apologise for that technical glitch. It's giving me a bit of a sweat, I can tell you that. So let's see what we get. Okay, so we drag Civil 3D onto this screen, and we're away. Whether I can work at an angle, I don't know. We'll soon find out. So the first thing I'm going to do here is open the drawing that I want to put in here, and I am having difficulty seeing.
Let's get you closer.
Yeah, okay.
Grab the two tables, I'll grab
Yeah, ready? Whoa.
Yeah,
Yep.
exactly.
To me, to you, to me, to you.
Right there.
Yeah, that's got to be better, hasn't it? Okay. So, panic over, 2 minutes behind. So this is our site. Yeah, as you can see, it's in the UK. Yeah. And in Scotland, up here towards Glasgow, the southwest, our site is there. And as I say, if we just actually turn the aerial photography on here, so that we can see the aerial that's there. 1, 2. This is playing up. It's not playing a game today. Yeah, if we could. You ready? Steady, go.
Oh, that looks like it's enough.
Okay. I've lost one of the. Yeah. It really is not my day today, is it?
I like to sing.
Hey! Not seen one of those before. It is actually worth filling these things in, you know. You do occasionally get a response from Autodesk. Has anybody ever filled one in and got a response? You filled out plenty. Okay. Right, let's see if we can bring this back to life. One, two. Yeah, I think we do need that music. Groovy dudes. Okay, we'll forget the mapping information and we'll just zoom in on the site. Yep, which is here. As you can see, this site has got quite a lot of contours on, and I have run a road around the site here. Yeah, and the red lines where we're going to be building the retaining wall. This alignment here is the edge of the sidewalk upstand, because I made this particular road using this assembly, and the red line represents that point as the road goes round the track there, if that makes sense. Yeah, so what I'm going to do is just delete that, because we're going to tie into that, if you remember from my PowerPoint, which I'm going to have to open and put on the other screen, aren't I? Yeah. Now, where were we on that? I really appreciate you guys being behind me on this. Yeah, as you can imagine. Yeah. And if you remember, what we're going to do is we're going to build the retaining wall. It's going to link to that blue line. Of course, the back of the wall, we need to get cut and fill into the existing ground. And we're going to be drawing vertical designs for the top of the wall and the bottom of the wall. Yeah? Okay, so the first thing we need to do really is just have a look at the lay of the existing ground under here. And this is a standard civil thing to do. We can go to profile and create a surface profile based on the existing ground, and we can add this and draw it into our box on screen. Yeah, So if I go create profile view here and press the profile there, you'll see we get a profile as the alignment goes around the road. And as you can see, it's a pretty smooth profile because I've already put the road on, yeah? What we're going to do now really is I'm going to turn this into an alignment. So if I go to alignment creation tools, sorry, not alignment creation tools, if I go to alignment and create alignment from objects, and I choose our polyline, yeah, and tell it that I'm happy with the way the polyline is, yeah, I can call this alignment something like wall, yeah. I don't want anything between it, but I'll turn this into an alignment, and there you see it's there. I'm just going to turn the surface properties of this surface off to border only, so that you can see it more visually. And again, what I'm going to do is I'm going to profile this new alignment, yeah, based on what we've got there. Now, that's the existing ground underneath that line there. But what we're going to need to do here is I need a bigger box because I need to work on this a little bit better. So I'm just going to go to the profile view properties, yeah, and I'm just going to tell the elevations of the profile to be a little bit larger. I'll have 4 meters one side, so I'm at 146, and we'll have that 160. Yeah, and press OK, and you see it just makes the box a little bit bigger, yeah. And really what I want to do is see how this and that interact with one another. So I'm going to superimpose it. I'm going to select this profile here and superimpose it onto that one, if that makes sense. So superimpose profile into this box. Now if I do superimpose that profile, notice that it goes right the way around my wall. So it'll look a bit difficult to read on here if I do it all the way. So I'm going to tell it to only do it between certain points. Yep. So in this case, I'm going to choose that point there. Let me zoom in a bit as my start point. And that point there as my end point. Yep. And then you'll see that when I press OK, it puts the profile in position. The reason I want to do that is because I really want to see where that land is so I can tie into it. Yeah? So you see I've got the profile for the top and the bottom of the wall. Right, let's see if we can get back to the PowerPoint and make sure it doesn't... So let me put this up here and play. Right, okay. Where's my clicker gone? Here we go, right. So what we have is we have a line for the wall which we've turned into an alignment. We've got the cut and fill of the existing ground. And what we want to have is the top and bottom of the wall. Are you with me? Bottom of the wall, top of the wall. Now the way I'm going to work this is we're going to work on the shape of the wall that's like that. Yeah. Now Civil 3D on surfaces doesn't like vertical features. So we're going to put a very slight slope on this. Yeah. So that it is not vertical. Yeah. And to get that, I'm going to use a 9,800% slope, because the higher the figure, the steeper the slope. Yeah, it works on that equation there. So we're going to have a little slope on our design, on our cross-section, if you like, of the wall. And essentially what's going to happen there is that those two red lines will be near vertical. Yeah. And this is what we're going to end up with. This is a geometry we're going to use. We're going to turn it into a corridor. Everybody knows what a Civil 3D corridor is, don't they? Yeah, but Leo, do you think it's necessary? Do you think it's necessary? Yeah. Necessary? Is it necessary for me to drink my own urine? No, but it's sterile and I like the taste. So when we come to do the corridor, this point here, this target point here, we'll be targeting our alignment. Does that make sense? Yeah. And it will also be targeting an alignment which we're going to draw for the bottom of the wall. Yeah? The top of the wall is going to be targeted at the top here. So as this is extruded, you like, along the course of the wall, this will grow, yeah, between one target and another. Yeah? Of course, we're going to have to put some sort of geometry down here in order to link in to this line, yeah, to fill in this gap here, which is where our housing's going to be. But nevertheless, that won't be a problem. And finally, we're going to target the existing ground up here for cut and fill. Yeah. And we've already got the existing ground profile, and we've already got that projected edge of the sidewalk, haven't we? We've got those two profiles already. What I'm actually going to do is add two more profiles. One that signifies the bottom of the wall, and notice I've put it up from the targeted ground, and one that targets the top of the wall. Yeah. That way we can run this profile. Yeah. The pavement upstand will target this black line. The bottom of the wall will target the bottom of the wall line. The top of the wall will target the blue top of wall, and the cut and fill is going to target the existing ground, which should produce us some sort of effect like that in Civil 3D, which will give us a surface with all those targets. Is everybody so happy with that? Yeah? So we've got top and bottom of wall, which we're going to look at making. But that top of the wall doesn't have to be variable, it could be flat. You could draw profile flat, of course. Same with the linear bottom, yeah? Or you could have them of a fixed height, top and bottom, yeah? So you've got the possibility of using all these, but I'm going to use the most complicated scenario where both top and bottom of the wall are varying, yeah? Now to do this, we're going to use, basically, we're going to be using the generic sub-assemblies inside Civil 3D. A bit freaky, but does anybody use those? Yeah. I can tell you use them, Leo. Yeah. Freaky. Freaky naughty. And we're going to use link, slope, and vertical deflection to define the two near vertical lines. Yeah, this is the help file. I know it doesn't look like that, but if you put a slope on that goes at 9,800, it will work. Yeah. And we're going to use link, width, and slope to do the top bit. And, whoops, wrong way. We're going to use the lot grade to do this geometry at the bottom to link in. And finally, we're going to use a basic cut, ditch, slope thing for the cut and fill. Now, I usually use my own cut and fill, but I'm going to use the one that's shipped with Civil 3D so you can see how it works. So let's see how we can go about building this wall. And we're on this screen now, aren't we? So the first thing I need to do is draw the bottom of the wall profile. So if I go to profile here, profile creation tools, select this profile box. I'll just bring the box onto the other screen. Yeah. And I'll make a different design profile, call it Design Profile A. And all I'm going to do here is just start drawing the bottom of wall. I better give it a name. Bottom of wall, okay, I can't spell, but you get the idea. Yeah. And when this box pops up, you'll see I can use all these tools to draw this bottom of the wall. For normal Civil 3D users should be familiar with this, but I'm just going to draw it using the bottom of the wall starting there. We'll have it going over there. It doesn't really matter. I can make this as complex or as simple as I want. If I tie it into the end here, it means the wall will tie into the existing ground, which is good of it. So there you see, that's the profile for the bottom of the wall. Yeah. I'm now going to make a profile for the top of the wall. Yeah, same thing. Yeah, choose a different style. I'll choose style C. And again, I can make this as complex or as simple as I want. But in this case, I'm going to start the wall. Come on, object snap. over here, and then we'll go up fairly high, across, down. Yeah, again, I can make this as simple or as complex as I need it to make it flat, and then we'll finish the wall, say, up there. So now what I've got is the two profiles I need for bottom and top of wall. All I really need now is an assembly, yeah, to run across this. And we can just create assembly from here, create the assembly down there, I'll call it wall, yeah, press OK, and put the anchor point there. Remember that anchor point is going to follow the bottom of the wall, yeah. So what I need to do now is add some assemblies to that, and I need the tool palettes on screen to do that. And here they are, here are the tool palettes. I'm going to use the generic tool palettes that I mentioned, the freaky ones. And I'm going to start with a lot grade. Now, if you want to know what these do, you can just press function 8, but I know function 1 to go to the help, but I know I haven't got an internet connection, so I'm not going to do that. I'm just going to put the lot grade there. Remember, it's this point here that's going to target the edge of that sidewalk. Yeah? Then I'm going to put these link slopes and vertical deflections in. Let me just put one on. And oh no, it goes in the wrong direction completely. But if I re-examine the properties of that, right click, whoops, come on, right click, properties, come on, properties, where are you? There you go. And then bring it on the other screen. Come on, you're on the wrong screen. Here we go. I can go down to this and I can change its slope. I'm going to make it 9,800%. And I'm going to make it vertically go up by, say, 10 meters. Yeah. So you should see now that I'm beginning to build the side of that wall. And then the next thing I'm going to do, I'm going to put a link width and slope at the top here. Again, if I can crick my neck to see this properties sheet. I probably want the width a little bit smaller, say 0.5, and I want it flat at 0%. Yeah, so that it's going to be a flat slope. And again, I'll just attach this to the top here like so. Yeah, and then once more, I'm going to put a link vertical slope in. Again, I'm going to use the value of 9,800% because I want this to go down by, say, 0.5 of a meter, like so. Yeah, and I will place that there. And very finally, I'm going to put one of the basic cut fills things on, which will hit there. And it's got a ditch on us, this guy, hasn't it? I don't know whether you guys use this, but I'm probably just going to make sure that the values for the ditch are pretty small. So I'll have a 0.2 there, a 0.2 there, and a 0.2 there. Yeah, and that should make it a nice little cut fill. So okay, I've got everything I want there. Remember, the ones that are involved in the targeting are this guy here, and our cut fill. These other two guys, this one at the top, isn't being used as a target. So usually what I will do is I'll rename it not for target, or not for target, NFT, NFT, yeah. And I'll rename the other one as well, not for target. So I know that I'm not going to be targeting them during not for target. I might spell that wrong. I can hardly see at this angle, but you get the idea. So there we go. Next thing I'm going to do is make a corridor of this, because I said it was all about corridors. So let's make the corridor. Let's call it wall. Yeah. The alignments of the wall, remember, it's going to follow the bottom of wall profile that I made, isn't it? And the assembly I'm going to use is the one I've just made, and the cut fill is going to target the existing ground. Press OK, and then this box opens. Yeah. I like to get my corridor frequencies pretty low, so I'm going to do them every meter. This is a 2-second. You don't have to do this, but it will make it a lot nicer to view. And then I'm going to start setting the targets. and this box comes up. I just press targets there. Now, you see the targets I'm not going to be bothered with, I've labelled. Do you see? The lot grade, the edge of the lot, remember, that's going to target the, it's going to target the line around the pavement, isn't it? So I'm just going to add that as a target. So the end of the lot's going to hit that pavement target. And then it's going to target vertically as well. So again, I just choose the edge of the side and tell it to target the vertical profile that I drew up here, if you remember. And then, of course, the top of the wall, the all-important top of the wall needs to be, top of wall needs to be targeted. Looks like I called it layout 2, sadly. Yeah, I should have called it top of wall if we were going to do this properly. Yeah. Press OK, OK, and then press OK. And away we go. We should have a corridor. If I look at this in Object Viewer, yeah, which is on the other screen, of course, yeah, you will see quite clearly that we have got, hopefully, a nice retaining wall. If I can only navigate on this second screen, I'd be okay. Let's try that again. There you see, there's the wall. Yeah, drawn in situ. Does that make sense? Now, that really is the quickest way of doing that. And Leo, you know, I've been to the Great Wall of China. I have visited the pyramids of Giza. I've even seen a grown man satisfy a camel. But never in all my days have I been able to make a retaining wall so quickly in Civil 3D. Okay. So back to the PowerPoint, I suspect. So that's making our surface. We can also make a surface of that with a corridor surface, of course. But we'll move on from this because I want to take you to the next step, which is creating a solid model. Okay, we've made a surface model. The next step up is to make a solid model of that. The reason being, surface models are great in Civil 3D, they're fantastic, but you can't really take them out anywhere and do anything with them. They're great for showing a quick mock-up of what it's going to look like. But if you're building a wall, you really want a solid model to get its properties out of. And what we're going to do is we're going to take the targeting principles we used before, target it as before, you know, to the top of the wall and to the bottom of the wall. And we're also going to add things like stepped footings. Do you see? Because the footings don't follow the bottom of the wall. They're always horizontal. Also, we're going to look at variable width footings for our solid model. Yeah? A cantilever design needs to have larger footings the more earth it's holding up, because that's what takes the load. So the higher the wall gets, yeah, the larger the footings need to be. But you don't want variable footings. The variable footings you need to be in distinct, discrete sizes. You know, 1 meter, 2 meter, 3 meters, like that. So that's what we're going to do here. And there you see the example of the way that the footings can be different sizes to hold different loads. Now, there's some stock retaining walls in Civil 3D. Has anybody used these? No, because they're not very good, are they? I've tried my best to use these stock retaining walls. And do you know, Leo? They're about as useful as a poop-flavoured lollipop. So we don't use those. So we have to design our own. And do you know what we use to design our own? Subassembly Composer. Yeah? I suspect that maybe 50% of this audience has never used Subassembly Composer. Is that right? Yeah? Hands up who has used it. Well, that's about right there. Maybe 60% haven't used it. Yeah? What Subassembly Composer is it comes with Civil 3D. You might not have installed it when you put the product on. And if you need to put it on later, just go back to add and remove features and tick the box to install Subassembly Composer. I'm going the wrong way, aren't I? Come on, go the right way. Yeah. So let's just think of the assembly that we want to design. Well, if you take the basic wall that we just had, yeah, we could make it into a solid by just basically filling it round, couldn't we? Yeah? Where the bottom of the wall is targeted there, as it did with our surface, and the top of the wall is targeted there. We probably need an attachment point there to attach our cut and fill to. Yeah? But if you think about it, these target points that we're going to design in Subassembly Composer will appear in our targeting box in Civil 3D. Yeah. And if we take it a step further and put the footings on, we probably need to have another profile to design where the footings are, which needs to be stepped. Oops, wrong way. And this point here will be the target point for the top of the footing. And there are other types of variables we'd want to put inside our assembly, which will enable us to change it when we come to placing it in there. And these will appear on the assembly side, do you see? Top width, foot offset, foot height, drop width. So we've got to think about putting these in our design for Subassembly Composer. Yeah. And then we come to the variable width footings. Now this is a tough one, because as the wall height changes, as it gets bigger, this foot width has to change and get bigger too, so that the cantilever will actually work. And to do that, I'm just going to use the mechanics of a very simple table. I'm going to say if that wall height is less than a metre, we're going to have a 1.5 metre foot width. If it's between 1 and 2.6, we're going to have a 2.5 metre foot width. And if it's greater than 2.6 metres, we'll have a 4 metre foot width. You could have a lot larger table. I'm just demonstrating the point here. Yeah, and I want to show you that we're going to work on this very simple table. Yeah. So before you start, create a specification document, is my advice. Yeah, something like this. So don't crack open Subassembly Composer, roll up your sleeves and try and get working, because you'll get lost very quickly. You need to think about your design first. Put a specification document together. Yeah. Now, is it necessary to have a specification document, Leo, do you think? Necessary? I'm going to use that quote again because it's my favourite. I can use it twice. Necessary. Is it necessary for me to drink my own urine? No, but it's sterile and I like the taste. So yeah, we're going to refer to this specification document all the way through when we're in Subassembly Composer. Right, let's see how we go for this now. So, Subassembly Composer, you can't see on my other screen, but I'm just opening it up. And I'll drag it across onto our main screen. For those of you who've seen this before, or haven't seen this before, all our geometry and functions are on here. This is a flow chart that shows you how we build things. We can see the properties here, and over here, just there is a preview of what we're going to be building. Now, what I'm going to do first of all is I'm going to click here and I'm going to put those variables that you see on my specification document. I know you can't see from the back, but I just take these parameters and I'll put, say, top height. That'll be the height at the top of the wall, and I'll make it a default of 0.5 of a meter. Yeah. If you guys can help me out, if I put something in that I'm not saying, tell me. So the next thing is drop height. That's another variable. Now I know that these variables need to be in there because I've made my specification. Yeah, and again I'll have that 0.5, and then we'll have another one, and the next variable is going to be called foot height. So that's the height of the footings are going to be. Yeah, again I'll get that to 0.5, and then we'll put another variable in here, which is a final variable, which is going to be, you see from my sheet, I'm going to have a foot offset. Yeah. And foot offset, and again I'm going to make that 0.5 of a meter, like so. So those are all my variables defined. Remember, these will show on the box when I come to insert the assembly. I'm going to go target parameters now because I want to target essentially the top of the wall. Top of wall. So I'll type that in there, and it's going to be an elevation target. I can't have spaces. And top of wall, and it's going to be an elevation target because the top of the wall, we need to know where it's elevated to. And I'll put a default value in of say a preview value of say 10, yeah, and that should put the target on the preview box there. Now I also want another preview for bottom of wall, if you remember, or top of footing. Yeah, we put that in there, and again it's going to be an elevation target, which is going to be say -2 underground. So again, you can see from this box here that let me zoom in so you pan it over so you can see where my targets are going to be in reference to my in reference to my anchor point of the assembly. So let's start putting some points in. To do that, it's best to sequence things in this throw chart. Some people just drag points into here, not a good idea. Let's drag the sequence on, and we can give this sequence a name. I'll call it points. Points, okay, I can't spell. Double click in there, and then I can drag my first point in. Do you see, there's the point? Yeah, it's put it on the anchor point, but I don't want it on the anchor point. I want it to be up towards the top of the wall. So I'm going to actually tell the properties here, yeah, to change it with an angle and a delta y. So it's from the origin point, yeah, and I want it to go up by 92 degrees, nearly vertical, and I'll send it up, say, to 8 meters, yeah, and that puts the point up there, not quite near the top of the wall, do you see? But I'm going to override this, do you see this elevation target, so that whenever that top of the wall changes, it's going to hit the top of the wall. Did you see it change there? That's my first point. Second point, let me drag this in, yeah. The second point, I'm going to change this in delta y and delta x, and I'm going to change it in x ever so slightly with that top width variable. So if I take minus top width in here, yeah, it will make the new point just over here, 0.5 of a meter from my original 0.1. Yeah, and has it done that? Can I see from where I am? Delta x, delta y. I've spelt it wrong, haven't I? Yeah, what did I call it? Case sensitive? Top height, I called it. No, it's not case sensitive, but it's idiot sensitive, I think. Yeah, so there we go. So that's the top one. The next one I'm going to drag this down is 0.3, which is going to be down. It's going to be that basically drop height there. So again, I'm going to choose delta x, delta y from 0.2, and I'm going to make it minus in the y, of course, minus drop height. Yeah. So you can see how I'm constructing the points in this assembly. Yeah. Those points there. So the next one I want, 0.4, probably needs to be a point down here somewhere. So I'm going to note it from the origin, and I'm going to make sure it's 88 degrees. I'm going to just have to change it to angle and delta y. Yeah, my angle is going to be 88 degrees. Yeah, and I'm going to take it -1 down. -1, -1. Come on, there we go. And it's going to take that down, as you see from there. Let me just see if I'm going the right way, because I can't see from this angle. I'm going the wrong way, so it needs to be 92 degrees. But I really want that not to target where we are. I want it to target this top of footing. So I'm going to override that so that it does indeed target the top of footing there. Yeah. Next point I put in, yeah, just going to move it over a little bit. So I'm going to choose my final point there, and I'm going to choose the foot offset as the direction for this next point. So it takes it round in this direction. Yeah? And then take the next point, which will take me down by the foot height. So again, I need to go minus for the last point, minus foot height, like so. Yep, so that takes it down. Now we've got to consider our very important foot width. Remember, that's been defined by this table. Yeah, we want the foot width to be dependent upon the distance between the top of the wall and the bottom of the wall. Now, I've got to put a variable in there to control this. And to put the variable in, I just click out this flowchart and I'll add another sequence in here, and I'll just call it variables. Because I actually do need, to put some variables in there. The first variable I want to define, again, I just drag the define variable in there. The first variable I want to define is the wall height. We need to know the height of this wall. And that's going to be the difference between the y-coordinates of this point here, P1, and this point here, P4, isn't it? So I can just put an expression in. It's quite a simple way of putting expressions in. I just choose P1, find its y value, and take away P4's y value. And that will give me a variable of wall height. And as we run this across the alignment, the wall height will change. So that's the variable that we choose. But I also need another variable called the foot width. And this is dependent upon foot height. So how are we going to do this? I'll put it in first, foot width. And we'll just pop back to the PowerPoint so I can explain this in a little bit more detail. Okay there. Right. So how are we going to get it to calculate this all-important foot width? Well, you see the table is there quite simply. And we're going to use an if statement. Has anybody used an if statement before? One. Well, you know, Leo, this is going to separate the men from the boys. From the possibly feminine and the definitely Canadian. So you look at this if statement, it sometimes can go over people's head, but this will make Subassembly Composer useful to you. Let's just spread it apart a little bit first, because the if statement works like this. It says, it gives you a condition first. It says, is wall height less than 1? Well, if it is, it's going to give you that number there, 1.5. If it isn't, it's going to give you that number there, 2.5. So even though it looks complicated to start with, the if statement's very basic. It asks a question, and if it's true, it does one thing, and if it's false, it does another. Now, that caters for 2 of our 3 possibilities in this table. So what we're going to do is we're actually going to concatenate the if statement, so that we can say, give another if statement, which says if wall height is greater than 2.6 meters, then we'll return a foot width of 4. And if it's not, we'll return 2.5. And all I'm going to do is put that other if statement in there like that. We've concatenated the if statement. Right? So if wall height is less than 1, we do that. If it's not less than 1, we say, is wall height greater than 2.6? If it is, we do that. If it's not, we do that. So we get each of our figures out there with this if statement. And that's what it's going to look like when we write it into Subassembly Composer. But I'm hoping you guys have all understood that. Great, fantastic. Because that's quite a complex topic to look at, really. Let's just have a look. I will actually copy that out, because I can't be bothered typing it in. copy. And then I go back to Subassembly Composer, not Civil 3D, Subassembly Composer, and I'll go down here and I will Control V to paste it in. And it looks like I've missed a bracket. Yeah, okay, so cool. And that's our if statement, yeah, which is going to control the width of that footing. Now that I've done that, I can continue putting my points in. So, what I'll do is I'll make another sequence here. Whoops, come back here, you. Yeah, there we go. Double click, and I'm going to add more points. So my next point here is going to be point 7, which is going to start from point 6, but it's going to go back based on that foot width that I've just defined as a variable. Yeah? Oh, maybe it's not. Let's have a look. Did I call it foot width? It is capital sensitive in this case. Oh, it doesn't like it for some reason. Variable type, I forgot to give it a double. There we go. Fantastic. So if I go back into here now, point 7 is defined as minus the foot width. Is that looking? Yeah, it's spot on. I don't know what the green thing is though. That could be a problem. Yeah. No, that's my cursor, that's why. Right? So let's do the next point, which is going to be up by this foot height that we defined. Yeah. But obviously I need to choose point 7 to go up from. And then the final one needs to be where this and that intersect. Let me show you that on the PowerPoint. PowerPoint. And click. Going back, aren't we? Too many animations on this side. So there we go. That's where we got to. But we've got to find this point here. And because foot width changes, we're not going to know the actual dimensions of that level, are we? So I need to find a point that coexists of an extension of this line and the extension of that point. Does that make sense? Yeah? So let's see what we can do on that. So let's go back to Subassembly Composer. And at this stage, what I need to do is add what we call an intersection point, do you see? And I drag this down, and I want it to be the intersection between 2 points and a slope. My first point is going to be point 3 at the top, yeah, which I want to come out down 9,800%, nearly vertical. And the next one's going to be point 8, is it? Yeah, and I'm just going to extend that to there. And you see, it gives me the confluence of the two. Just check that looks all right from here. Yeah, that looks good. So do you see we've got the points that make out the side of the retaining wall. So now what do? Well, we need to put meat on the bones. We need to add lines to join these points together. Now that's quite straightforward, and it's quite a... I'll add another sequence. No, I won't add that. I'll add another sequence first of all here, and I'll double click to go into that sequence, and I'll start adding links, which are lines. So if I drop the first link in, I can choose that I'm going to link point 1 to point 4, for example, which puts that line in. Yeah? Drag another link in. I'm going to link point 1 to point 2. Yeah? This is a little bit of a laborious task, so I just ask you to bear with me. Next link in, point 2 to point 3. Yeah. Next link in, point 3 to point 9. Yeah. Next link in, point 9 to point 8. If I screw up, guys, tell me. I can hardly see the screen. And link 6 is going to be point 8 to point 7. Yeah, and then finally, not finally, but we're going to have point 7 to point 6. and then point 0.6 to 0.5. And there we go. We should have a fully encompassed assembly. Do you see? Have I missed something? Oh, right, yeah. Well done. You guys are on my side. I appreciate that. Yeah, link. So we'll put it right at the bottom. 0.4 to 0.5, was it? Yeah. It doesn't matter which way. Either will work. Yep. So now we have a fully encompassed. But we want to make this into a solid, so we've got to put a shape in the middle of it. And that's what this guy does here, this shape. So I bring the shape in. Yeah. And all I need to do is choose something inside that, and it will make a solid of it. I can now finish with Subassembly Composer. I've done my design. Yeah. So what I'm going to do here is just save this file. Yeah. I'll call it AU 2015. Why not? Oof. And we've done. That's our subassembly composed, if you will. So now what we need to do is just look at the PowerPoint just to make sure. So now we've got that. Yeah, we're going to make it into a solid model. That's all we need, really, was that assembly to include in our corridor to make that. Let's see how it's done. Civil 3D time, I think. So, I think here I'll start a new one. Basically, on this drawing here, it's the same thing you've just seen. I've started my assembly here with this, yeah, with the lock grade, just as before. What I'm going to do, I'm going to bring in a new assembly, and to do that, I'm going to have to import it onto a tool palette. So I'll probably just right-click here and make a new tool palette. I'll call it AU 2015. Yep, and then just right-click and import subassemblies. Yep. Give it a source file name. Let's say AU 2015 and press open. OK. And it will put it on there. I should have really saved it with a picture, but I didn't. But when I click it now, to bring this subassembly in, notice my variables are at the bottom here. The top height, the top width, yeah, the drop height and so forth. All these are changeable. So if I wanted the foot offset to be 0.7 of a meter, I could do. I'd change it to say 0.6. Yeah. And then I can just drop my assembly in the drawing here on that particular tab. Do you see? And it's in. Done. All I need to do now is maybe just put the basic cut, fill, ditch, slope thing on. And I should have an attachment point there because I designed that point in my assembly. Can you remember? Yeah. And, you know, I'm really ready to run this now in the corridor. So let's make a corridor of this. Yeah. You all understood how I built it. I'm using the retaining wall alignment again. And again, I'm following the bottom of the wall profile. Yeah, the assembly I'm using is the one I've just designed with my Subassembly Composer thing in there. Yeah, and the target surface is going to be the existing ground just as before. Yeah, I'll just change the frequencies as I did first time round, just so it looks a little bit nicer. 2, 2, 2, 2. Yeah, and we'll look at setting the targets. Now the targets are a little bit easy to understand now, aren't they? Because I gave them names in Subassembly Composer that make sense. Yeah? So, first of all, we've got this lock grade we need to target just as before. Yeah? So there's no change in how we target that from the previous exercise we had. Yeah? And then we can target the top of the footing, which we haven't got yet. So I need to draw that. But at this stage, I can target the top of the wall, can't I? Like so. And this will make a corridor without the stepped footings. Yeah. So press OK. OK again. Rebuild the corridor. And there you see I have my corridor, which if I look at it in Object Viewer, and if I can navigate at this angle, you will see I've got my my corridor there that's essentially ready to go. Just look at it from an elevation, but you'll see the footings are not stepped. Can you see that? The footings are actually following the bottom of the wall. That's not what we want. We want the footings at discrete levels. Yeah? So how are we going to do that? It's easy. We're just going to draw a profile. Another profile. Let's do that. So go to my profile box over here. Yeah. Again, pretty standard Civil 3D stuff is drawing profiles. You click the box. I'll call it footing levels. Okay, I've spelt it wrong. It's in Russian, is that? Yeah. And I'll give it another design level. I'll call it A, and I'll place this on here. So when we come to drawing the footings, because when I'm level, I'm just going to use simple lines. Yeah? So I'll put my footing there, look. And then I'll draw another one underneath. I'll try and keep it flat. It's really weird. It doesn't look flat from this angle. It really doesn't. Yeah? But do you see what I'm doing to get these footings in place? I'm just drawing a profile out. Yeah? So there you see, that's where my footings are going to be. Now, of course, I can go back to my corridor here. Corridor properties. Corridor properties. Yep. And I can go to the targeting parameters again. And now I've got this profile drawn, I can target the footing levels like so. Yeah? And that will rebuild my corridor so that my wall, yeah, now has stepped footings. And you can clearly see the stepped footings on the elevation. Yeah? And if we look at this, you should also see that we have variable width footings too. Do you see? At certain sizes of wall, the footing widths change. Yep. And this gives us essentially the basis for our solid model. Okay, so the next thing I'm going to do is I'm going to create a solid model from this. Simply highlight the corridor, and you see where it says extract corridor solids? Yep. Click on that, and this box comes up. It's just going to make solids from this corridor. I'm going to add all my regions here. Yeah. And I'm going to take the lock grade off because this is actually, I just want the information from the, remove. I just want the information from my subassembly. Do you see? And I go next. I usually add it to a new drawing, to be fair. So I'll call it AU 2015 solid. Yep. And hit save. And then create solids. And what that has done is it's just gone away, open. If I can find the drawing, what do I call it? AU 2015 solid. Not in that folder. Where did I put it? AU 2015 solid. There she blows. And when this opens, you'll see it's created a solid model of the wall. Do you see? Yeah. Let's put some presets in. Visual styles, make it hidden so it looks a little bit better. And there you go. You know, using those simple steps, we've got a full solid model of our retaining wall from Civil 3D. Everybody happy with that? Yeah? And it's a quick and easy way to make that solid. So we've got this solid model, and we're away. Now I've got, and we're going to be looking at. So when you saw this slide originally, what did you think? Did you think you'd be able to do it so easily? No? You've got a full solid model there. Just check where I am. Yeah, okay, Leo, guess what? You're on. We've seen it all. Grit, determination, and incontinence. Okay, so now we're going to look at improving this. How much time have we got left, gentlemen? About 10 minutes. Right, okay, we're just going to look at the Inventor stuff then. I'll quickly run through the Revit stuff. So we're going to round trip export. Now you might have seen exports to other things, yeah? But we're exporting into Inventor and Revit here, and I want it to be a round trip export. None of this just taking it out, working with it and then forgetting about it. I want to take it out, improve it, and I want to bring it back in and use it, yeah? In both cases, Revit and Inventor. And, you know, there's a lot going on here, isn't there, Leo? What's my next quote? Come on. Yeah, it's a 2-in-1 menage a trois. You pay double for that kind of action. Okay, so with Revit, it's pretty much well documented, is this, the shared coordinate system for Revit. Have everybody used the shared coordinate system? No one. One. Wow, 2, 3, 4. That's a productivity enhancement on the subscription site. Yeah? You basically need to download this. And then what happens is you take your Revit model, which is 0, 0 is probably there and it's square. And then you've got your civil model, which is basically thousands of meters away from a 0 point. Yeah? And all the shared coordinate system does is it essentially takes the Revit model and it puts it into the right coordinates in civil. Yep. We're not going to look at that, but hey, I've put notes on the AU website that shows you how to do that both ways, in and out. We're going to look at also linking to Inventor. Now, Inventor's a solid modeler. Yeah, it works on parts and assemblies and sketches. It's a very powerful solid model. I've used it now for about 15 years. Yeah, and you can do things in Inventor that are so awkward in AutoCAD. So to take your solid model out of there and put it into Inventor so you can really put some good models in there and then bring it back into AutoCAD is a fantastic way of doing it. Okay, Inventor's more of a mechanical-based product. But you'll see that it works on parts which are assembled together into an assembly. But the same could be said about our retaining wall. There are many parts to it. For example, up there, we might have pipes for weeping holes. Yeah? We might have buttresses or dead men. Yeah? And we can assemble these together inside Inventor quickly and easily. And when you come to build it, each component has its own reference. So our complete wall will be made of the wall, it'll be made of the footings, and maybe it'd have a buttress in, which will be made of rebar and stonework and other stuff. So there are many, many files that make up an Inventor-based document. Let's have a look at taking this model out. I'll do it quickly. I've only got 15 minutes left. 5? Really? Wow. Okay, so I'll show you quickly how we do it, really. The essence. Yeah. The essence is that we have the model here, which is refusing to work. Come on. Okay. I'll tell you what we'll do. We'll run through the PowerPoint and I'll explain it, as I seem to have locked up again. You know, I've been doing this class for around about 12 months now, and this is the first time I've had problems with the equipment. Right, okay, as there's very little time left. Yep. Essentially, the import and export routine is covered in a document that is on the website. Yeah? It takes you through exporting from Revit and exporting from Inventor and importing from Inventor. But the essence that we have there is quite simple. All you do to get it into Inventor is you take it from the coordinates and you move it down to 0. If you don't move it down to 0, when you export it from Civil, it's unusable in Inventor. Yeah? And the way you get it out of Civil is you type ASYS out. You take it out as an ASYS solid. Then you can open the ASYS solid inside Inventor and work on it. Then when you're finished, you save it as an ASYS file again. And you will bring that ASYS file back into Civil 3D. And if you saved the reference points you used, you can put it back into its global position. Yeah? Don't forget the supporting documentation for all this on here. I really wanted to show you one of the imports, but time is not on our side. I'm really sorry about that. It's been a little bit of a cock-up with the equipment. Anyway, I hope you've enjoyed this particular class. Please feel free to fill in the surveys. Yeah, as I say, I'm a first-time speaker, so I really don't know how my style's gone down in this class. I don't know whether you've all learned something or whether you've enjoyed it or not. So please fill in the form. At least it'll give me something to read on the plane on the way back home. Question and answers, it's a good time. If you want to email me. I'm on Twitter if you need that. Are there any questions? Wow, no questions at all. It leaves me to say one more thing. Gentlemen, look after your balls, and they'll look after you. Thank you very much.